Hello. Today we're going to be talking about pointers, but before we do, let's do a little review of structs. We're going to split this lesson up into smaller videos so that it's easier to upload and easier to digest. Okay, so here's the problem that we want to solve. Create a function that calculates the slope of a line through two non-vertical points entered by the user. So non-vertical just means we don't have to worry about the denominator being 0. Okay, so what do we do to solve this? We'll open up our design steps and then we'll follow the steps. The first thing that we need to do is to make the signature. So I have here my editor open and a skeleton of my C program started. So ang signature is simply what are the things that we should accept as inputs and what is the thing that we'll give back as an output from this program. So looking at the program, it seems like we need to accept two non-vertical points entered by the user. Two non-vertical points. So we need some way to represent the point. How do we do that? Okay, before we answer that question, let's take a step back and see that for every problem that we solve, we're actually doing an invisible step. And that is, we're thinking of a way to represent the information that's in the real world as data that we can manipulate in our program. Okay, here's an illustration of that. Quick sidebar. Okay, so on the left, you see here's the real world. Sometimes in computer science speak, this is the domain that we have. And out here in the real world, we have many different forms of information. We have storm signals maybe, and somebody's age or weight, or somebody's letter grade. These are all things that exist in the real world that for our programs to be relevant and useful, we need a way to represent and manipulate as data. So notice, our programs, they can't deal with information directly. We need a way for the information to be converted into data that our program can manipulate. Okay, so that's one step that we're doing here in the signature step of the design recipe. Now, for example, we might decide to represent age with a number, let's say 5. Maybe we'll say it's an integer because you can't have fractions for age. Let's just say that. And then maybe storm signal can be something similar. It can be on a either 0, no storm level, or 1 or 2 or 3 or 4. And then maybe a letter grade, we can represent it using a character. So do you see? We're taking information that exists in the real world and we're thinking of how we represent that information as data in our program. Also, at the other end, after our program spits out the data, its output, we have to figure out how to interpret that data. So if my program comes up with a 5, then I need a way to know that that 5 represents the age. Or if the program comes out with the storm signal 3, for example, then I need a way to know that 3 means there's signal number 3. Okay, so there are two steps in our program. We need to represent them, information, represent as data, and then we'll also need to interpret that data as information.